So today in class we were deciding whether or not a table was a proportional relationship when we had an x and a y value. The easiest thing and what we want you and suggest you to do is to find what we call a constant of proportionality. And if that constant of proportionality exists, then this is a proportional relationship. I find that constant of proportionality by dividing my y over x value, or my dependent over independent variables, and I want you to get in the habit of showing your work every single time. So on our first table here, question number 5, we have our x column, we have our y column, and I want you to divide y over x for every set of quantities that we have in this table. Can't simplify that fraction. I don't want you to change it into a decimal. Keep it as is right now, and I end up with 3 over 2. My second set of relationships that I have here, my y would be 6, my x is 4, and when I divide, I end up with 3 over 2 as well. Now we can't assume anything. Yes, two values are the same, but we can't assume we have to show all of our work. So y over x for the third row here would be 30 over 20. I can divide by 10 and I end up with 3 over 2. But we still have one more set of values that we have to show, and I'll show my work down here since I'm running out of space. Remember that we're always dividing y over x. 60 over 40 I could divide by 10, I could divide by 20. If I divide by 10, you see that right now it doesn't look the same, but this is not in complete simplified form. If I divide by 2, I get 3 over 2. Since each one of these ratios, 3 over 2, 3 over 2, 3 over 2, and 3 over 2 is the same, I know that this relationship is proportional. And if your teacher were to ask you what the constant of proportionality is, my constant of proportionality then is my 3 over 2 in each one of those cases. Let's take a look at number 6, where my table looks very similar, but I have some different values here. Again, my process is the same. I still want to look for that k equals y over x to see if this is a proportional relationship. When I start dividing my y over x, this is a fraction here. I don't want you to change this to a decimal. I want you to keep it as a fraction of 1/5, or a ratio of 1 to 5. When I divide y over x for my second row, however, I get 15 divided by 3. 15 divided by 3 is 5 over 1. Now, piques your interest because you have different values here in different orders. However, they're not exactly the same order. 1 to 5 is not the same thing as a 5 to 1 ratio here. So let's try the third one. 10 divided by 2 is 5 to 1. Over here, 40 divided by 8, y over x, is also 5 to 1. But since they're not all the same, and I have this one value right here that is different, this is a non-proportional relationship. Proportional, sorry guys. And if it's a non-proportional relationship, then there is no constant of proportionality here, so we can't say what that k is. This is a non-proportional graph on the right. The left-hand one, number 5, is a proportional relationship.